Hi guys, so we left off talking about our condensation and dehydration reactions, and then we went through our hydrolysis reaction. So if you remember, condensation is building up. We're putting monomers together, and every time we make a bond in between monomers, we get a water molecule as a product. Hydrolysis was the opposite of that, so we are breaking things down. Each time we are breaking off a monomer, we need a water molecule in the reactants to do this. Okay, so let's talk about how this relates to our bodies. So we have this thing in our bodies, it's called ATP. It's called adenosine triphosphate is the unabbreviated terminology for it. But anyway, so in this we have triphosphate. What that triphosphate means is that we have three phosphates, that functional group we went over yesterday, attached to the rest of the molecule. So what happens here, guys, is we need energy in our bodies. How do we get energy? Well, we eat sugar. Sugar is energy for us. That is our main source of energy. You need sugar, guys, okay? You always need to have sugar in your bodies. So if you ever go on a diet where you don't eat sugar, it's probably not the best thing. Now, there's sugar in a lot of things, guys. There's sugar in fruits, there's sugar in pastas and rice, all these different things that we eat. So it's not just like, oh my goodness, Mr. Communal says I need sugar. I'm going to go drink, 24 cans of pop and I'm going to go have a dozen donuts. No, it doesn't work like that, okay? But anyway, so whenever our body needs energy, we eat sugar. Sugar fuels this molecule of ATP. So this is called ATP, this whole thing down here. When we need energy, what's going to happen is we are going to cut this bond right here. We cut that bond. In cutting that bond, we get a release of energy. It's my best lightning bolt there. Okay, so in cutting that bond, we get a release of energy. What this is, guys, is we actually have 1, 2, 3 monomers here. They're phosphates. What we're going to over here is 1, 2 monomers, and then this one broke off. So what type of reaction is this? Well, when we go from here, from ATP, which has 3 phosphates, to ADP over here, which has 2 phosphates. The DP means diphosphate. This reaction, we are breaking it down. We're taking one off. So this is a hydrolysis reaction. If we're going the opposite way, going from ADP to ATP, which we can do as well, this would be a condensation reaction. Okay? So this is how this stuff relates to our bodies. All right, so we're going to start on carbs today, guys. I have, for you guys that I made, a little chart. Looks like this. We're going to be using this guy today as well. So make sure you have him available. But anyway, so talking about carbs, guys, there's a lot of things in the world that are carbs. Everything on the screen here is a carb. And a carb is just something that has sugar in it. That's all it is. So our structure of carbs, I give you these weird formulas down here. We'll go over them in a minute. But carbs are going to have 3 main elements. They're going to have carbon, they're going to have hydrogen, and they are going to have oxygen. And that's going to be in a 1 to 2 to 1 ratio. What that means is however many carbons we have, we need that same number of oxygens. And whatever those numbers are, whether you want to choose the carbon or the oxygen, the hydrogen is going to be twice that number. Okay, so I'll do another example here, and then we'll go over to the chart and fill that one out. Another example of this, let's say we had C10. Well, the O is that same number, so it's also going to be 10. The H is going to be double that number, so that's going to be 20. And that's the whole format for a carb, guys. It has to be in a 1 to 2 to 1 ratio. If that is not in a 1 to 2 to 1 ratio, then, well, it's no longer a carb. All right. Okay, so here is your flow chart, guys, or graphic chart, whatever you want to call it. This will help you throughout the chapter, guys. So as we go through this, as we fill it out, make sure you look over it every night. But our structure is Cn, and N is just a variable. H2N, ON. Okay. So an example of this, C6, H would be double that, H12. O, same as that first number, so it would be 6. Okay? So there is your structure. You guys can take a second, copy that down into your chart. And what I'm going to do here, guys, is as I go through them, I'm going to give you like, a minute or whatever to copy it down. And then it's going to go away, and we'll do the next box. If I go back to the PowerPoint here and don't erase it, it'll stay up there. Okay, so here is our monomer. Now, we talked about monomers yesterday, guys. A monomer, single unit. Once we put two monomers together, we get a polymer. Now, we're going to be going over these macromolecules. Each one of our macromolecules, whether it's a carbohydrate, a protein, a lipid, or a nucleic acid, every single one has its own specific unique name for monomers and its own specific unique name for polymers. Okay, think of this one. If you were here today, right, with all of us, yeah, tons of people back here, right? If I was talking to you guys, I would say, hey, students, I'm talking to you guys collectively as a group. Now, that would be in comparison to the monomer name. I'm talking to all of you, students. If I want to talk about one of you individually, I'd say, hey, Johnny, what are you doing? Hey, Rebecca, what are you doing? All right. I'm talking to that individual student. Monomer is a very general name, just for one unit. Monosaccharide, that's a very specific name. That's like me calling on an individual one of you. All right, and that is for a specific macromolecule. In this case, monosaccharide is for carbohydrates. So let me go back to our chart here. So we got our monomer. Let me enlarge this a little bit. Oops. Okay, so carbohydrate, monomer is going to be a monosaccharide. Anytime you guys see saccharide or saccharose, what that means is sugar. So anytime you see that, that means sugar. Now, once we put two monosaccharides together, we get a disaccharide. All right. Disaccharide, this is two monosaccharides. Okay. So I don't know, a bunch of scientists were, chilling one day, trying to figure out the names of this stuff, and they said, well, we'll call one a monosaccharide. Okay, lovely. One monosaccharide. I got it. Well, what happens if we put two monosaccharides together? And the guys were like, well, we'll call that a disaccharide. All right, so 2, disaccharide. How about 3? Well, and after a while, guys, it was like, oh, why do we got to give each one of these their individual names? And they said, well, let's just make it easy. Well, after 2, we'll call it just a polysaccharide. So what they did here, guys, is 1 has a special name, monosaccharide. 2 has a special name, disaccharide. After that, they just said, anything after that, yeah, we're going to call it a polysaccharide. So this is anything that has over 2 monosaccharides bonded together. All right. So there is your monomer and your polymer of carbohydrates. So if we put 2 monosaccharides together, and this is what I meant, guys, you're going to need to know your condensation and hydrolysis reactions. If we put 2 monosaccharides together and get a disaccharide out of it, well, what type of reaction is it? Are we building up? Or are we breaking down? Well, we're building up. We're making it bigger. So that would be a condensation or a dehydrolysis reaction. If we do that, if we go from a monosaccharide to a disaccharide, what are we doing with water? Do we need water or do we form water? Well, since it's dehydration, condensation reaction, we would get water out of it. Okay? So make sure you guys need to know those condensation and dehydration or hydrolysis reactions. Okay. Under carbohydrates, guys, I'm going to write actually the saccharide thing. So I will say saccharide or saccharose. That's sugar. Carbohydrates are sugars. Okay. Just to give you a little more information on it. All right, and the last one we got to go over is the function. And I would just write that in so we could finish up carbohydrates here. What is our function of carbohydrates? Well, carbohydrates are sugars, so that is going to be what the sugars do for us. They give us short-term energy. All right? That's our sugar. So there is our function of carbohydrates. Okay. So we are done with that one. Now, we are going to have 3 main monosaccharides of carbohydrates that we have to know. We have glucose, it's the main one you guys know, fructose, and galactose. All 3 of these are going to have the same chemical formula, and that's C6H12O6. Well, how do 3 things that have the same formula have different names? Shouldn't we just like C6H12O6? Shouldn't they all just be glucose or fructose or galactose? We don't have to give them all different names. It's all the same chemical formula. Well, what's different in them? Here, if you guys look, the way they're put together is slightly different. They all have C6H12O6. They all have 6 carbons, 12 hydrogens, and 6 oxygens, but the way the puzzle pieces, the way those elements are put together is different. We call that an isomer. It's a molecule with the exact same chemical formula, but the way those atoms are arranged, it's a little bit different. So that is an isomer. Okay, so we already talked about a disaccharide. Now we're going to go over 3 different of our formulas dealing with disaccharides whenever we add monosaccharides together. So, glucose. Well, where do we find glucose at? Well, that's just normal sugar, guys. Nothing crazy there. Fructose. Fructose, the monosaccharide, is found in, just kind of like the first syllable there says, fruc. It's found in fruit. All right, fruit. So it's fruit sugar. The last one, galactose, our last monosaccharide, galactose. Don't worry about the GA. It's not found in a galaxy. I always ask every year, I go, okay, where do you think we'd find galactose? And students are like, in the galaxy. Well, yeah, it's going to be in the galaxy. It's going to be on Earth, obviously, if we're studying it in biology. But no, galactose, don't worry about the GA. Second thing, lactose. Think of where you hear lactose. People who are lactose intolerant, they cannot properly digest milk. So, galactose is a sugar found in milk. So, glucose and fructose together make a disaccharide called sucrose. Glucose plus glucose gives us maltose. And then glucose plus galactose gives us lactose. So all 3 of these ones here, guys, these are our disaccharides. All right, so 3 different disaccharides. All right, after this, guys, we get to a polysaccharide. This is just a bunch of monosaccharides bonded together, or a very long, polymer. It's just more than 2. Okay, so how do we store our glucose? Well, we don't want our glucose just floating around our whole bodies, guys. That wouldn't make sense. If it was all floating around our bodies, yeah, if we need it, it's like, hold on, let me find something. It's like when you're like in your room and you don't put something back where you got it from. It's like, oh, where did I put I know this is me all the time, guys. Where did I put my wallet? There's like 3 places in my house I put my wallet, and it's like, did I put it here? No. It's always the last place you look. I hope it's always the last place you look. You don't find your wallet and then keep looking for things, right? Yeah, that'd be kind of stupid. But anyway, come on, lights. There it goes. Anyway, so what we do here, guys, is we like to store our glucose so that way it's easily accessible for us. In animals, which we are animals, we store it in this molecule called glycogen. So glycogen is a whole lot of glucoses bonded together, very long polysaccharide, full of glucose. Why we do this again? If we need it, we know where it's at, and it's all bonded together. It's all in one area. Plants, a little bit different. They store it in a molecule called starch. Okay, so they don't have glycogen. Plants have starch. All right, we will do this one tomorrow, guys. All right, this little example here. So we will call it a day here, and we'll pick it up tomorrow. Have a good day, guys.